This video is on the objective determine the p-value for a hypothesis test for the mean of the differences for the paired data. And this is the second video on this objective. I'm hoping you saw the first one as well. And let's just get into it. Alright, so if you want to see more about the objective, what they have to say on it, please click on more instruction at the bottom and look at their videos, their notes, their examples, and hopefully those help you as well. Alright, so here a researcher wants to compare the heights of males between generations to see if they differ. To do this, he samples random pairs of males who are at least 18 years old and their fathers. He then splits them into a sample of fathers and a sample of sons. Suppose that data were collected for a random sample of 11 pairs, where each difference is calculated by subtracting the height of the son from the height of the father. So they're going to take the father's heights, minus their son's height. Look at those differences. Assume that the heights are normally distributed, right? So that way we can say that the D bars, right, the average, the sample average for the sample differences has a distribution that's a student's t distribution with 10 degrees of freedom, right? Because they'll be doing 11 pairs, 11 differences here, and they're saying that here later. The researcher uses the alternative hypothesis, that mu d is not 0, meaning that there is some sort of a difference between the heights of, fathers and their sons. The null hypothesis would be that mu d equals 0 and that there is no difference on average between fathers and sons' heights. But the alternative hypothesis here is that there is a difference on average between all fathers' heights and their sons' heights. Right. Using a test statistic of t equals 1 point, so they're giving us the test statistic here. We don't have to look at a sample or anything. T equals 1.971, which has again 10 degrees of freedom, right? One less than the number of differences you'd be taking. Determine the range that contains the p-value. Now I'm just going to do a thing where I find the p-value with the calculator, and we'll come back to this table as well. So again here I'm going to have the average of the sample differences. We'll have a t distribution with 10 degrees of freedom here. And the way that they gave us the alternative hypothesis that the population mean difference between fathers and sons' heights is not 0, right? Meaning that there is some sort of difference in the generations, in the heights of the generations. All right, so if that's the way the alternative hypothesis looks, then what we have here is a two-tailed test, right? It's a not equal. And that dictates how I'm going to calculate p-value, right? So I'll draw up this t distribution. All right, the number line here is t values, and it's a symmetrical bell-shaped curve where the t-score underneath the peak is a t-score of 0. And to calculate p-value, right, we need to know where our test statistic lies. Now they said the test statistic was at 1.971. That was the test statistic. Now this is above the mean. All right, and if I'm doing a two-tailed test, how you find the p-value is, if my test statistic is above the mean, I just take the area to the right and double it. All right, the p-value is going to be this area, but then times 2, right? Because it's a two-tailed test. So you could do that, or you could find the area to the right of positive 1.971 and add to it the area to the left of negative 1.971, and those two put together give me this p-value. All right, so I'm going to find this area to the right. Now I'm going to do it on my calculator. This is the t distribution. Remember how to find the area under a t distribution. I go to that distributions feature and down to number 6, TCDF. Now, if I'm finding this area to the right here, the lower value is my test statistic, 1.971. There is no upper value because I'm going to the right forever, so I'm just going to put in some big positive number like 5 nines. And the degrees of freedom here was 10. Alright, so this area is almost 4%. Right? This area here is approximately 0.0385. But I'm going to double this because for p-value in a two-tailed test we take one of these areas and double it. So times 2. So the p-value for my test statistic is approximately 0.077. Right. That's 7.7%. That's between 5 and 10%. So back in the options, I could use my calculator and say, oh, the p-value is between 5 and 10%. All right. As we saw, it was about 7.7%. Now, if you were using just the table, that's also not a problem. Remember, the test statistic here is 1.971. And we're looking at a t-distribution with 10 degrees of freedom. So I'm in this row. And then let's see, where does 1.971 fall? Well, let's see, it's bigger than this, but not bigger than this. So 1.971 falls between 1.812 and 2.228. So that means the area to the right of 1.971 is between 2.5% and 5%. But then you got to double these because you're talking two-tailed tests, right? Not only would I want the area to the right of 1.971, but I want the area to the left of negative 1.971, or double that. So if the area to the right of 1.971 is between 2.5% and 5%, and we double those, then the p-value is going to be between 5% and 10%, which I have stated down here. So either way, use a calculator, use a table, and you can state, the range that the p-value is going to fall in. All right. And again, I'm hoping that watching me work over this, looking at the more instruction if you need to, reading the answer explanations, I'm hoping all this stuff helps you out when you're working on this kind of material on your own. And thank you very much for watching.